Hi guys, there were a couple of questions from section 1.3, number 25 and 29. Actually 29 is a little shorter than 25, so I'm going to work 29 and then we'll see if we have time for the same for 25 also in this video. If not, I'll make another video for that one, okay? So I already wrote the function, number 29, our function f of x is 2x plus 3, which of course is a linear function. Because remember, x is to the first power, that's what we call it, linear. So they ask us for two things. Number one, to find this expression we call difference quotient. Again, the name because you have a subtraction, which also means difference. And then, of course, you have a fraction, which is also known as quotient. That's why they call this expression difference quotient. Very, very important expression in calculus, because hopefully very soon we'll talk about derivative. And derivative obviously comes from this expression. So this is probably one of the most important expressions in calculus. Anyway, it's going to be algebra. Right now, this is algebra. Next section, you have a little bit in calculus. Right now, it's just a matter of computing this and come up with what they call simplified form, okay? So as you know, if f of x is 2x plus 3, what's f of x plus h? So from your algebra, of course, you remember anywhere you have x, you're going to replace x plus h, because that is your x. Remember, whatever is inside the parentheses is always your x. So just plug in the x plus h. Don't forget there's a number in front, so you do want to put that in parentheses. So that just becomes 2 times x, which is now x plus h. And then, of course, plus 3. So this is your f of x plus h. I'm just going to put a bracket around it. So that way we can distinguish. And then, of course, minus f of x. Well, f of x itself, of course, again, put in parentheses because that negative has to be distributed. That's a common mistake. People don't put parentheses and then they forget to distribute the negative. And then all over, of course, h. So usually what happens, actually not usually, all the time, at the end of the day, when you try to come up with a simplified form of this difference quotient for any function, actually, the h in the bottom will always basically disappear, okay? So if the h in the bottom doesn't go away, something went wrong. I'm going to do some algebra here. I'll distribute the 2. So that becomes 2x plus 2h. Again, we still have the 3. And then minus, also we'll distribute the negative. So that becomes minus 2x, also minus 3, okay? And then all over h. So now, as you can see, the 2x cancels the negative 2x. The 3 cancels the negative 3. So all you're left with actually is just 2h over h. And of course, you can cancel the h's. So basically, your answer is 2. So notice that this expression, this difference quotient, doesn't involve x or h, because some of them at the end, they still have x and h. I think number 25 will be like that. But for this one, because the difference quotient is always constant 2, so because part B asks you to fill up the table, so it actually doesn't really matter what x and h are, because this is a constant value, right? So this is going to be basically 2 for all the rows in that table, okay? So I'm just going to show you the one of them because they're all going to be the same idea. So for example, the first row says, I'm going to do it up here. So we're done. This is your difference quotient. Kind of answers part A. So this was part 8 because they asked for the simplified form of difference quotient, which of course in this case just happened to be 2. Now for part B, he asked you to fill up the table. So the first column are the x values. The second is the h value. Of course, in this case, because the fact that there is no x or h left, the answer is just going to be, so the last column for the difference quotient will just be 2. So for example, the first row says x is 5, h is 2, and then of course difference quotient, which is also going to be 2 in this case. So this will be your first row in the table. Now the rest of the rows are going to have same, of course, value at the last column, because that's going to be always your difference quotient. So it doesn't really matter what x and h are. Now this is a special function, it's a linear function, so that's always going to happen. But of course, if the function is not linear, like number 25, there will be x and h, and of course, once you finish your simplified form of the difference quotient, you can just plug in the x and h. But for this problem, the last column for part B is always going to be 2, right? Because there is no x and h appear at the end. Okay? So I'm going to stop this one. It's already almost 5 minutes. And then I'll make another video for the problem number 25.